Dear students, today's lecture 3 of design of continuous beams. So let us go through the details of the various design considerations which we have to taken into consideration as per Indian Standard Code IS 456 2000 version. So let us start. Now, before going through the design of continuous beams, we have to first of all understand what is the actual meaning of continuous beam. That means what are the basic requirements or basic features when we will say that this beam is a continuous beam, and what are the various advantages of designing a continuous beam in reference to or in comparison to design of simply supported beam. So first of all, beams with more than one span are called continuous beams because they continue over the intermediate spans. So whenever there is a beam of more than one span or multi-span, as in case of multi-story buildings or residential buildings where we need to design or we have to provide the continuous beams which are having more than one span, two span, three span or multi-span. Now continuous beams, as I've already discussed, they are most commonly constructed in multi-story buildings, as well as you may see in case of bridges, bridge type of structures, you will find the beams or slabs, they are multi-span continuous beams. Now the span length may be unequal, or continuous beams may have equal span length or unequal, and the moment of inertia of the cross section may also vary from one span to another span. There may be possibility that a continuous beam may have same dimensions throughout its length. That means moment of inertia may be same or it may be different. That means maybe dimensions of the beam can differ from one span to another span. Now you can see in this photograph where a multi-story building is under construction. It may be two-story building, three-story or multi-story, and you can see here very clearly that there are number of columns are there. Column number 1, column number 2, column number 3. No, it is column number 1, column number 2, column number 3, column number 4. Maybe along other side you will find also multiple columns. And if you see in this particular beam, you can easily understand or can see that the cross section of this continuous beam is varying. Here depth of the beam is less, but here depth of the beam is more. Similarly, in this another structure, here you will find that two spans of this beam, they have similar dimensions, but here depth of the beam changes. So as we have discussed, that span length may be unequal as well as movement of area, movement of inertia of the cross section may differ. So if a beam of multiple spans may be of similar dimensions, may be of different dimensions, so that will be come under the design that is continuous beams. So you can, here I have highlighted that this is a 3-span continuous beam. From this figure, it is almost we can say that all the spans, span number 1, span number 2, span number 3, they are of equal length, but they can vary also. So this is an example of 3-span continuous beam. It may be 4-span, 5-span or multi-span. Now what are the basic advantages of designing a continuous beam? We can design these 3-span beams individually, that means single span, but why we are going to design this as a single continuous beam, that means a continuous beam in a single go. So few advantages we can try to understand. These beam has lesser value of maximum bending moment as compared to simply supported beam. If you analyze these beams as a continuous beam, then you will find whatever be the maximum bending moment value you will get from the bending moment diagram, then that maximum value in case of continuous beam will be lesser than if you analyze these beams as individual beams, as a simply supported beam. Now, as you know from the previous class, when we have studied design of concrete structure 1, that whenever you have to design a beam or a slab, then basically the reinforcement as well as dimensions of the structure member depends upon the magnitude of maximum bending moment. Now if here we compare these beam with in comparison to simply supported beam, then as we have discussed, maximum bending moment will be less. So if maximum bending moment is less, then your design depth of the section will be lesser. Now if the depth of the section is less, definitely self weight of the beam will be less. Also you will when analyze the continuous beam, you will find the maximum deflection along the span will also be lesser as compared to simply supported beam. Larger span length can be taken between the supports. So you can increase the span length also. So all these parameters, if you take into consideration that the section will be decreased, self weight will be decreased. Definitely if self weight is decreased, then the factored bending moment which you will calculate, where you will include self weight also. So reinforcement may decrease, as well as the material required for the construction of this continuous beam will be lesser. So ultimately the whole of the section will be economical. So here we are getting the advantage, that means this design will be safe as well as economical. However, when you have to do the analysis, as you are well aware, a simply supported beam is a determinate structure, very easy to solve, but if a continuous beam, then it will become an indeterminate structure. So analysis will be little bit complicated. You have to use various methods which are available for the analysis of indeterminate structures, like a Kani method, movement distribution method, and various other methods. But however, nowadays softwares are available, so this complication can be easily solved. Very easily the software will be able to design these type of indeterminate structure. Now design of continuous beam as per IS 456 recommendation or 456 guidelines. So we will be adopting various steps in the design, let us first of all understand what are the various type of steps which we have to follow while designing a continuous beam. So let us divide it into number of steps. Step number 1, for simplicity we have divided the analysis part as well as design part into steps. So step number 1, you have to enlist whatever the data or information available from the design problem. Whenever you are given a design problem and you have to solve it, you have to do the design, some data will be given. As clear span is given, grade of concrete, grade of steel. So whatever be the information available, you have to enlist all this information in step number 1. Then we will follow step number 2. Now in case of step number 2, first of all we try to approximate effective depth of the beam, because in the design start of design you don't know what is the depth of the section. So first of all you have to assume the depth of the section. That means you have to assume the effective depth of the beam section. Here we can take the help of Indian Standard Code IS 456. You can refer the guidelines given in clause number 23.2.1 of IS 456, which we have already discussed in the previous lecture number 2. So let us just have a relook at this guideline. So here you have to assume the effective depth of the section as per this clause based on the deflection criteria, because Indian Standard 456 limit the deflection value. So what code is saying in 23.2.1 A part, span upon effective depth ratio. When the span of the beam is up to 10 meter, then depending upon whether it is cantilever or simply supported or continuous. So L by D ratio, this is the, here it is clearly mentioned that span to depth ratio are not greater than these values. So this is the maximum value. As in case of continuous beam, L by D ratio as limited by code is maximum is 26. So that means you can assume any value below 26 in case of continuous beam, or as per the other guidelines also. So clause can be referred for other type of cases. If span is more than 10 meter, then other few guidelines are available. So you must go through in details about these guidelines, grasp the guidelines, and accordingly you can decide what should be the effective depth of the section. Let us, for example, we have taken here for a continuous beam, as per code, L by D ratio should not be greater than 26. So that means less than 26 you can take any value as per your experience. So in general, whenever we are doing design, so in practical, currently in practice, span to overall depth ratio. Now here is effective depth, but the span to overall depth ratio of 10 to 15 are generally found to be economical. These limits are based on the experience of various designers. So it is found to be economical in case of simply supported and continuous beams. So you can take any value between 10 to 15 or 16, 17, whatever you can, because here you are not deciding the depth of the section, but you are just assuming the depth of section, and based on that assumption we will do the analysis, and later on we will be applying various checks whether our assumption is correct or not. So if later on that section may fail in checks, then you can revise the section. So there is no hard and fast rule basically what should be the assumption in case of effective depth. So we will take into reference these value. So that means you can just assume the value based on. Effective depth is calculated by taking clear cover value. Now clear cover, what should be the clear cover? It depends upon the weather conditions, or you can say exposure condition. So based on the exposure condition, code is giving you guidelines regarding whether it is mild condition, whether it is severe condition, adverse condition. Accordingly, you have to select the clear cover. So after selecting clear cover, first of all you have assumed the overall depth, then you have taken the value of clear cover. So from that you can easily find out what should be the effective depth of the section. Now, as we are very much aware from the analysis, when we are doing the structure analysis and we are finding the bending moment as well as drawing the bending diagram, so generally bending moment varies as square power of the effective span. So that means when we have to decide the effective span, then that is very much important, because if effective span is increased, then its square power bending moment will increase. And as the bending moment increases, your section dimensions as well as reinforcement will vary. So we have to be very careful while deciding what should be the effective span. So code has again given us some guidelines. So this will come under step number 3. Step number 3, calculate the effective span as per clause 22.2 of IS 456. So how we will be deciding the effective span? So let us go through the guidelines. Now for beams that are not built integrally with the support, so that means very in simple language we can say that the beams which are not fixed beams, they are not casted integrally with the supports. For example, beams supported on brick wall. You are just putting first of all the brick walls, and then you are casting a beam on the on the brick walls. That means brick wall will be used as a support to the beam. So brick wall is casted. First you have casted brick wall, then later on you are casting the beam. So they are not integrally bonded to each other, or integrally casted with the support. So that type of beams, that means simple support beam, effective span can be calculated by this formula, that L effective, that means effective span is equal to LC, that is clear span. Clear span means the distance or span length between the two supports of a span plus effective depth, or center to center of supports. So here first of all you have to calculate L effective by this formula, then you have to get the value of center to center of supports. So whichever is less, that will be used as effective span in case of the analysis of the beam. Again it is written that LC is the clear span, D is the effective depth of beam, and center to center denotes the center to center distance between two supports. Secondly, where we are more interested in this semester, that is continuous beam. Now what is the guideline as recommended by code for selecting or for deciding the effective span for continuous beam? Very first step is, here code is restricting few things. If the width of the support, that means there is a continuous beam which is supported on various supports. Now if the width of the support VW is less than LC by 12, LC means clear span by 12, that means if width of the support is less than this, then you can take length of the, that means effective length of the span, as we have already mentioned in first step, that is 22.2a. So these guidelines you can follow. Now, if the width of support is more than this or 600 mm, whichever is less, so that means first of all you calculate LC by 12, whatever its value, then you compare it with 600 mm and take the lesser value. Now, if the width of the support is more than this lesser value, then you have to consider these two cases. For end span with one end fixed and the other end continuous, or you can say for intermediate span. So here we are having two conditions. First is end span with one end fixed and the other end continuous. Now first of all try to understand. Suppose you have an example of, or you have to design a continuous beam of 3 span length. 3 span mean there will be 4 supports. So one will be the end span, another side there will be an end span, and in between spans will be known as intermediate span. So if you are going to design first of all the beam for the end span, extreme end, it may be left end or right end, where one end is fixed and the other end is continuous, or you have to design for intermediate span, then L effective can be taken as equal to LC, that is clear span. So this is clear. Second, for end span with one end free and other end continuous, in that case you have to take into consideration effective span by this formula, LC plus D by 2, or LC plus half width of discontinuous support, whichever is less. So you will be able to understand all the guidelines when we will be going through a design problem. Third step is spans with roller or rocker bearing. So these type of spans generally when we design a beam or slab in case of a bridge structure. So that time you have to take into consideration effective span will be calculated by taking distance between the centers of the bearing. So in this particular subject we will be mainly focusing on all these type, maybe these bridge type of beams or slabs. Currently they are out of syllabus, so we will be focusing on the all the guidelines. Third one is for cantilever. If there is a beam that is a cantilever beam. Now normally mean if you are going to construct a cantilever continuous beam in case of a building type of structures, so you will be using these guidelines. L effective is LC plus D by 2. But if it form the end of a continuous beam, then you can take the effective span by this equation. So three steps we have discussed in this video, and later on in another next video we will be focusing on other steps of the analysis as well as design of the continuous beam. After that we will be directly switching to design of actual continuous beam as per the syllabus.